Thanks very much for coming. It's not a really good weather day, but we hardly able to predict in such long in front. We have some friends online as well, so we are live streaming this event. And by event terminal, if you heard of this, there are a few Ukraine nice girls started this event streaming company called Events Terminal. And the event is sponsored by FooCafe. They are like organize those events, providing the venue, the food, and so on. And my name is Rockie. For this event, it will be great that if you can post your question or start your discussion by @knockdata, and the people watching online can also post a question there. And that's my Facebook and my LinkedIn. If you are using WeChat, that's my QR code. And I started that knock data so that people can share and discuss what related to the data space. And it's roughly started 2 years ago. And we had, I don't know how many events we have, roughly once every month. And we always try to have events related to technology, not only business. So that is me. So I have different priorities for different values. And some space I left it open because some values I cannot identify it. But when see one thing, I will prioritize it. My goal is like make big data comes alive. My name is Rockie, and forever young. I believe you are able to remember me. And I want in this big data pipeline have an like helicopter so I will able to work inside but still keep an outside view. There are 2 topics today. The first one will be by me, called Modern Data Science, a 10,000 feet overview. And the next one will be by Amgard. He is one of the expert, and he had delivered a Danske Bank project called Deep Fraud Detection. He has no idea how to transform a bank transaction to an image like data, and which seems has a very good result. And if you have question, you can directly talk to him later on. And this is not like 10,000 feet, but that's the idea. So I can have an overview on the solution. I will talk 3 things. The first thing is called demography, and what does it have for modern data science. And that has started long ago, and I had not born at that time. But the thing, there are some dark age for machine learning area. I don't know if there will be another one in the near future. But the time now is very good, and this area is really hot. And I think it's quite fun as well. So for definition, this is some kind of definition. Artificial intelligence is quite a big domain, and machine learning is part of it, and the deep learning will be even smaller scale. If we put into categories, Then there's supervised learning, unsupervised learning, and reinforcement learning. And deep learning will be just something inside supervised learning. But that can be mixed together with, for example, reinforcement learning as well. So what is supervised learning? So to my understanding, there are some called features. And that features has label. Each data set has one label. For example, I'm prepared to sell my apartment. This is 3-bedroom apartment, 65 square meters, and 500 meters to station, and 1 kilometer to lake. And what I want to sell is, for example, 3 million. But after sell it, that will become a label. So that's the label. Later on, when new house come, we can say based on these features, what will be the predicted value, for example. And one of the algorithm, say linear regression. And what basically is that based on those features, so we put those dots on the coordination, and then we are able to draw a line. But this is a 2D dimension. It can go on high level, but we can not easily to view it. So it's easier to draw it on 2D dimension. Basically, just draw a line to see how to approximately to the result of the given data. I think this is the base of the machine learning. And another one is called the Logistic Regression. And it's quite similar, but that one is draw a line. And this one is put a plane. So we can separate different data and put on a category. For example, whether a person have a diagnosis of malignant tumor or benign tumor. And some interesting that this decision tree, I think this is quite commonly used. There are different variants, but the idea is that there will be one tree based on certain features. We can say it might go somewhere. Of course, if there are lots of trees, we can ensemble it and get a better result. But this is the idea of get one tree. If it's private, it's motorized, it's likely a car or motorbike. And it's public, might be one of these, bus, train, subway, and so on. And nowadays, that the neural network is one of the most common machine learning algorithm. The first one is the feed forward. So every feature connected to the next layer, connect to layer. Final layer, we have some result. It can be only have one, it can have multiple things. For example, some digit number recognitions. Is number 0 or 10 or 9? There is no 10. But this one, like discard all the structure information. And one algorithm used called convolutional neural network, because it has a relationship between different features. And the most common way will be used for image recognition, but other type of data, for example, these bank transactions, if we are possible to transform to a 2D dimension, that can also use this algorithm. the main concept is convolutional. So like put a small box and scan over an image and go to next level, doing it again, so that it can capture the structure information. The important part is that the structure matters in convolutional neural network, and the position does not matter. For example, detect a person in an image. It does not matter where the person appears. It's still a person. Then there is another type called the recurrent neural network. And that like when we do speak is one word by one word. And so it's recurrent often. So we can like draw like this way, or we can fade out. So it's continuously doing that. That's why it's called recurrent. And what the most important is that the order matters. When we speak, quite some time the order matters. If I said stupid me stupid is the same, but others might not. That is supervised learning. So basically for the data, we have some features and we know what it is. That is called supervised learning. And nowadays, most common way is we're using deep learning, either convolutional or recurrent. Then another type called unsupervised learning. And we have some features, but we don't know what it is. We just want, for example, categorize it. How can we distinguish between different data? For example, that like someone said, I like like science from 1 to 5, which level? Like sport, 1 to 5, which level? I hate music, which level? And talking a lot. And we might able to, based on these features, try to group those people to different categories, like white, green, and blue. But what this white, green, and blue mean, that does not matter. We are trying to group those people together, be based on certain characteristics. If we want to understand the meaning, then people can look into it to see what is this type of people, good at it, not good at it, what they like, what they don't like. There are quite many unsupervised learning algorithms. One of them called Disney. This is for the number recognitions based on photo. And we can try to put it in this way that every number can render it at a different color if we put on a 2D space. So they are roughly grouped together. For different type of data, we can do it similar as well, so that we can understand some data they are grouped together, some data they are not. And one of common way is called autoencoder. So we have this mushroom and goes some level in, and in the middle we have quite narrowed. We can either call it bottleneck, but clearly the data there is much smaller than the original one. So we can compress the data. For example, over internet, we can do that. So we only need to send that part of data, and we can reconstruct back the original photo. and it's almost same. If we over internet pass a small number of data, it's really nice that we don't need wait so long time to wait a photo or a video come out. We also like back up some data and use that way. It will be smaller, put an USB stick. That is unsupervised learning. If we go to the one very interesting, reinforcement learning, I think this is quite similar what kids learn. If we have a kids doing something, we said, good job, give a candy. If he's do something nasty, then said, no, you should not do it, no candies. And over time, kids will know that what he should do, what he should not. And this is quite same with this reinforcement learning. Based on certain environment, if we doing some actions, they either get a reward or get a penalty. And over time, they know what to do. There, for example, this AlphaGo, I think the main algorithm is reinforcement learning. So they try to play a game with certain person. If they lose, they know that that is a bad move. If they win, so they likely is a good move. But overtraining again and again, they will understand what is the best way going forward. And autonomous driving is another area for this one. I really would like to have a car so I can control it. I can put in my own algorithm with some cameras and radios so I can control. But unfortunately, there is no such car yet, so I can control it. Perhaps with some just gaming cars. So that is the part demography. And we are going to the any questions? If we have any questions. No? That's fine. And we are goes to workflow for how we do data sciences in steps. I have seen quite many people and quite many projects how they do it. I think it's somehow like this. So we first preparing the data, and that step can be short, can be really long. For example, I have seen that some project, after 6 months, they still don't have data yet for doing something real. And there are lots to talk about, like politics. How many politics in this preparing data? Because quite some organization, quite some department, they see that that data is their property. No other people allowed to touch it. And how we can do that and get the data for us to use is really take time. And after we get data, we can say we are coding the model, and we can train the model and evaluate it. And that 3 orange box is quite a narrow definition of data science. And like deployment and how to monitor and have a feedback loop, that's other people's job. Some role called a data engineer, and that's usually doing those parts. But between prepare data and coding the model, we usually need to do quite a lot. For example, see how the data look like. Is it good? Is it bad? So we need the data explorations. And likely the data is quite dirty. and we need to find a way to clean it. For example, how we handle those missing values, how we handle those extreme values. And we likely need to doing some data normalizations. If some example they are bad, so we need to do something for that. Otherwise, the whole model will go crazy. And that data is usually just the raw data. How we can extract the features from that one. And after that, we can do a real thing. I don't know that how many time we are prepared in the first phase, perhaps 80%. Yeah, 80%. So the real data science work like coding model, training model, and evaluation like 20%. But the people emphasize that part a lot, but not mention those parts is quite common way. So that is my view how to view the data science work. Then there are quite some tools. In order to doing data science, we need some tools. And the first one is, I think is important, is called data exploration, how we can explore data. Some tools like Tableau, Click, and they are pretty similar. And the one is called typical Spotify. Spotify is not that company for music. And another one called SAS. Anyone played those? Anyone have played those few? Which one?
I use SAS.
SAS. Do you like it?
No.
Why?
It's too rigid and it's too limited.
Yeah, and
Expensive.
yeah, expensive, and it's quite slow.
Very slow, and it's, I think it's going to. I don't think a lot of people use it in the future.
Yeah. And the other few, they have quite some nice features. If we just want to use it, they can be quite good. Try to understand how good the data is, how the distribution is. When I started doing it, I using Spark. I heard that is a nice tool, but there is no good exploration function. So I developed one called Spark HighCharts. It's still available on GitHub. If you are interested, you can go there. But nowadays, there is one called Chartify. Anyone heard of Chartify? That's by Spotify, open source by Spotify. Quite nice. I have one small example later. You shall give a shot. And there are a few other tools. One is called Facade, and another called Vega Voyager. These two tools are quite similar. Based on certain data, they can give you a graphic thing to see how the data is. For example, this one is called Voyager. Actually, you can use it by search. Go to the that link, vega.github.io Voyager, and you are able to upload your data set and to see how the data look like in different dimensions. Another one like this one is quite nice, and that's called Pair Code. I don't know if it's a company or it's a group, but that tool is quite nice and it's open source. I generally like open source tools because give me the possibility. If something not working, I'm able to do something. And then the next one will be Chartify. And this philosophy is quite similar with what I developed for the Spark high charts. So basically, it's you writing some code. So it's not a drag and drop tool. You need to write some code. But what you need to write is that first is how you want, for example, what's X column, what's Y column, and which type of graph you want to use. And others just massage it, for example, the title. Once we finished, we want to have a more nicer graph. Then we need to do something. But the basic is that X, Y, or might be Z, and then which plot we want. That is open source as well. And Python. There's another big community is for R, and R Shiny is quite nice, but I never played it, so I don't have much to say about R. Anyone like R? All right. Sorry to say I have never played. And for data cleaning, there are lots of tools. I personally like this one called Spark. There are a few reasons. The first reason is fast. It's much faster than other tools. The second reason is flexible. Do lots of things usually need one line of code. For example, fill in the missing value. Just need one line of code. I really recommend it if you want to do data cleaning or some called ETL job. This is quite a good candidate. And after doing all these things, we usually need to present the final result to business people. And there are different ways. For example, create a PowerPoint and create some graph. And one good way I really like is that have some animations. For example, this one I did quite a long time ago. This network usage behavior. So the data is quite simple. From which IP send to what IP, and what time is it, how much the package it is, and what's the application name. And after that, we can create some animation. For example, this one. So over time, how this pattern shift. Because that was I developed it a couple years ago. I don't remember exactly which color represents which application. But here is the code. You can see it. That's developed by D3. I think if you want to doing this kind of visualization to business people, D3 is a good choice. It takes quite some work, but the effect, whatever you can imagine. Then is data science libraries. There are lots of libraries, and here are some. I would say like TensorFlow by Google is one of the populist. And another is the Keras. It's quite simple to use compared to TensorFlow itself. Even I can understand it. And another one called PyTorch by Facebook. So I will say this TensorFlow and PyTorch, they are biggest competitor in this world. Then other tools, this few is I would say not that commonly used anymore. And like scikit-learn, and there are other tools as well. Lots of library. For example, the basic library NumPy. For example, this Panda, and something like Stanford NLP for natural language processing. For example, Jensen, and there are lots of libraries. But the top three, if you want to play, you should start with those three. I roughly spend 30 minutes, and I'm on time. But I believe the food is not ready yet. So what I have talked is quite high level overview. So there is no detailed information how we can use it, how we can doing it more effectively with better accuracy. My friend Amgad will touch it on convolutional neural network, object localization optimization. Quite hard to read it, and he had published the paper. Where is it? Yeah, and he had presented there as well. Now he fly from Amsterdam and come here and as a favor to present it. If you have those specialized questions, you should ask him. And there are a few levels. What I see, data science, that's how we categorize it and how we do it step by step, and what kind of tool we usually use. And that is the talk. And any questions? Without there is one called AutoML, if you heard it by Google, and that is try to put all the experience some data scientists have and try to doing some automatic machine learning. And also depends on which domain you want to use. For example, language translation, there are quite some cloud provider. You can directly use their API.
Typically, like for machine data that you're capturing or industrial data that you're capturing, run analytics for prediction or to find out some behavior which is abnormal. You have a time series data from a machine or from a plant or factory, and then you run and see if there are some abnormalities or something is failing or about to fail.
Yeah. So that is one of the main important that what questions you try to ask. And that's the first important thing. What question you try to ask, then we can go to the solution part, how to solve it. And for time series, there's quite some tools which on this. For example, on Spark, there is a Spark TS that is doing specialized for those. And usually when we visualize certain dimensions on time series data, you will get your answer there as well. Any more questions? I will try to see if there are any questions on Twitter. Notifications. Seems there's no questions come out yet. How to go there? No. I quite seldom using Twitter, so I don't have like. How many followers do I have? How to see it? Yeah. So I have 9 followers, but I will try to use it. Do we have more questions? Yeah, please.
I was wondering if you could talk a little bit generally about what industries use data science and which of the fields we talked about are used predominantly with industries, and also very broad question.
I believe nowadays almost all companies try to apply data science.
Yes, with an emphasis on try.
Yeah, and somehow it's difficult to get the real business value out from data. But the one we had tried together on Danske Bank, that there are lots of bank transactions, how we can detect